Oh, good morning, good afternoon, good evening. So, welcome to the presentation of um, a artificial intelligence for health data. Um, this is a project that we are starting by calling for technologies, and this is part of a sequence of eight presentations, three for call for technologies and five for standard that are reaching community comments. I said MPAI. Who is MPAI? Well, MPAI is Moving Picture, Audio, and Data Coding by Artificial Intelligence. It is an international, unaffiliated, not-for-profit standard developing organization. We develop AI-based data coding standards, but we also strive to attach intellectual property right licensing frameworks. So this is our organization. Maybe look complicated, but what is important is that we have development committees that are in charge of developing standard after a call for technologies has been issued and responses have been received. And then we have another series of groups who are working on preparing new projects for new standards. How do we develop standards? If you have a proposal, please come to us. We will study where this proposal can be used. These are the use cases. We define what are the functional requirements, and then what are the commercial requirements. When both are available, we should call for technologies like we are doing today for AI for health data, and then we start the development. And when the draft is mature, we issue it for community comments, and after that, we publish as a technical specification. So what characterizes MPAI is that we try to make explicit the computing workflow of AI applications. So what we do is to break up what are today generally monolithic AI applications into a set of interacting components that exchange data of known semantics to the extent possible, of course. Then, by means of this, developers can offer standard components that are or have an improved performance, and the humans can have the possibility to select applications, and they understand how the application operates. So this is the how our standardization can be characterized component based. And this is because we have small components called AI modules. We aggregate AI modules into AI workflows, and we execute AI workflows in a standard environment. And all this is contained in a standard called AI framework. So this is the framework. And by the way, what we are proposing or we are calling for is supposed to fit with this in the sense that we have elementary components that exposes interfaces with data of known, hopefully known semantics. These are interconnected, and then this is executed in this environment. And here we have the possibility to access to several services, including security services. Any standard create an ecosystem. MPAI develops standards. We have developers, we have integrators, we have consumers. Because we are dealing with artificial intelligence, we have the need to of an entity that we have established as a not-for-profit organization that we do not control. It's an independent organization. And this guarantees that the component, the AI modules and the AI workflows are interoperable, trusted, and available. And this is where you see this standard that is called the governance of the MPAI ecosystem. What is the MPAI ecosystem then? So we have MPAI producing standards. A standard is implemented. We have performance assessors that are appointed by MPAI, but operate independently. The implementer submits an implementation. The performance assessor assesses it, and let's assume it is okay. Then we have the established MPI store, whose task is to verify the security, test the conformance, and check the performance. I say check because the performance is not assessed by MPAI, by performance assessors. So now the implementer submits the implementation to the MPI store. The MPI store does the necessary test, and if everything is okay, then it makes the component or the of the workflow available on the MPI store, so that the user can download it, use it, and provide feedback on their experience. We have published more standards. Standards on audio, finance, human-machine conversation, neural network watermarking. We have technical reports on the MPI metaverse model. We have 5 standards published for community comments. And we expect that they will be approved as standards on the 29th of September 2023. So here they are. We have version 2 of the AI framework. What we have added is a security, multimodal conversation with extended features. And we have 3 new standards: one, avatar representation and animation; another is connected autonomous vehicles architecture; and MPI metaverse model architecture. But we have more, because we have, for instance, artificial intelligence for health, and we are calling for technology. This is what we are doing today. Object as scene description has been presented yesterday, and extended reality venues, live theatrical stage performance, will be presented on Tuesday. We have other activities regarding video coding to approaches, and we have one project on online gaming. Then I am happy to say that IEEE has adopted 4 of our standards as IEEE standard, and we have a 5th on its way. And I'm proud to say that all this has been achieved in less than 3 years. So let me go now to, so this is the list of the presentations, and I will stop presenting mine, and I will hand over to Anna, who will be the presenter.
Thank you so much, Leonardo. So now I'll present the specific call for technologies for our artificial intelligence for health. And the word federated, will play an important part on this project that has been developed by MPI. Myself, I'm also a representative of a Portuguese university, ISCTE, namely the ISTAR Information Science Technology and Architecture Research Center. But now I'm playing for MPI, and all our team is playing for MPI. And I'd like to express my thanks for your interest in this presentation. And we're going to try to show you the main points on the present work in progress. So this MPI AI Wedge, standing for Artificial Intelligence for Health Data, it's a project that intends to support the collection, the artificial intelligence-based processing of and access to health-related data. It means, in some part, we wanted to assure the governance of health data meaningful applications, and the functionalities of the project should be supported by a secure platform whose characteristics are defined from the technical point of view, considering generally applicable legal concepts, such as the well-known European GDPR. The motivation behind the proposal of this project came from a Portuguese project named mHealth that is financed by the National Science and Technology Foundation. And this project has designed a smartphone application that alerts the user and eventually medic or clinical teams for possible abnormal symptoms that might alert towards the occurrence of a COVID-19 infection. And we did this using a secure artificial intelligence distributed service-based platform. Like I said, that is the foundation for this, the idea I'm presenting here today in behalf of a vast team that has been working for the last year on this project. So our effort features a system leveraging AI for health, where, of course, we have end users, and these users use a personal mobile system. We can picture it as a smartphone that acquires and processes personal health data using artificial intelligence workflows and frameworks in the spirit of MPI that has been described by Leonardo. And we call this part of the more personal end user application like the AIH front ends. We have then what we call the backend. That's a centralized system platform that, under the right permissions, stores, processes aggregated licensed health data, health-related data. It also collects artificial intelligence parameter data from local processing models at the front ends, updating a central aggregated model if found necessary, and distributing an improved AIH model to the front ends to work with. That is, we are employing and envisioning a federated learning approach. Of course, third-party users are an important point, an important actor on this project, that under the right permissions may ask for health data to be processed or assessed. Eventually, licensed subsidiary data can also be funded into the system. In fact, next slide help us picture this big idea, schematic idea for this project, where we have the AIH Health Secure Platform that comprises different systems, services, and distributed services and APIs, as depicted in a picture. Central in this picture, we have, of course, the main services that reside at the backend that are composed of a set of tools to implement the needed services to securely store, de-identify, and anonymize data, control entity authentication, and assess and control access to data, and of course license and audit the access to this data that is stored in a secure vault. Sorry, not yet. I don't want yet. It's here. Okay, in a secure vault. The backend gathers data from all various sources. The end users, again depicted here by a smartphone, that provide it, and other external sources, like we've just said, and acts as a broker gateway with licensed third-party entities that request access to the data, in this case, the end user data, or the gathered data in the central platform. And if licensed, they can assess it, and they can ask to be processed. We'll go a little bit back, we'll go a little bit over that in a few slides. Notice also here at the bottom of the figure, the MPI store and all artificial intelligence services and processing should be MPI application standards regarding all the processing elements. We call it the AIH, or artificial intelligence models, for short AIHM. And they are needed to create the artificial intelligence workflows. Each AI model is basically defined by its function and data. So that's the reason we have different AI models here. Of course, like Leonardo said, MPI standards are designed to enable obtention via standard protocols of an implementation of artificial intelligence workflow. And the set, the corresponding AI models are what we need for our framework implementations. This should be selected for all the ones available from the MPI store, and maybe orchestrated to produce specific analysis for the entities that are requesting access or processing of the health data. Then, and also highlighted here, we have the artificial intelligence federated learning system that orchestrates the learning of a central model for medical diagnosis or prognosis, and namely by working as a medical anomaly detection tool that also works independently at the front ends of the end users. The central model receives model heights from the models trained at the client models at each front end user, and using it under the terms of a smart contract that should have been established between the end user and the AI backend. Again, we'll talk a little bit more about this later on. Then an improved model is obtained by the central system, and if in fact it is an improvement, it is distributed to the client models via model update. On the left of the figure, the end user mobile devices, we go to the next slide, which shows as an example of a front end, the main services and systems on the end user side. We can observe the intake of end user data, I mean, demographic and other relevant inputted data from the user. Then we have automatic sensing of biometric data acquired by eventually several personal devices that are connected with the mobile central device of the front end, the smartphone in this case, and the application. And of course, eventually data coming from other applications, internal applications of the device or directed sources may also be integrated into the secure data vault of our application. From here, it is assessed or by the local machine, and for instance, feeding the machine the training, the personalized training of this local machine learning model for the anomaly detection and issuing of risk alert for the user or for a third party granted permission to have this alert. And of course, this connection with the third party is, like as I've already expressed, connected through the interaction of the front end with the back end. It's short. Besides a personal health application, this front end represents the gateway between the user data, user-related health data, and any other sources for incoming or outcoming health-related data. And in the case of outcoming, that's towards the backend, like we've said. So, a fundamental requirement, because we have exchange of data and the exchange of sensitive data, is we require that this is secure and we secure it using blockchain and distributed ledger technology that enable the transparency and auditability of all the system. So every provision of or access to health-related data will require the emission of a license in the form of a smart contract that will be stored on the blockchain. This smart contract will contain information about the parties, the end user, and the backend, any third party eventually involved, if it is personalized, the data that is involved on the exchange to be stored or assessed, which type of processings are allowed, and the access conditions. So there are several processes going on, both at the IIH backend and IIH frontend, which include, of course, housekeeping services like scheduling, communicating, calibrating, and so on and so forth. And of course, this is an IIH platform, so inference services, processing data, and using machine learning models to produce results, at least to use by third parties, from backend to third parties, or in the front end for the user of the application, the front end. So other types of processes we have here, any authorized third-party entity may request access to data, as long as it's properly registered and authenticated within the system. And of course, it does that through the access of the proper APIs to request the access or processing of data. These requests may be chosen from a data catalog existing using a query interface. The catalog should provide the metadata with an appropriate level of detail. The third party may select any intelligent mechanism that exists to process the data and extract some type of results, as long as it has been authorized to do so. And of course, within the front end, we also have processing and inference over the personal sensitive data of the own user. And in this case, there's no need for licensing or granting of permission, and so no need for a smart contract. And still on the processes description, or the main processes description, any request by a third party in order to process data existing at the IIH backend is executed under the strict terms of an existing smart contract. This involves, like I said, the selection of specific services to process the data. And these services is based again on a choice that is made from a service taxonomy and is used in the smart contracts. The third party entity accepts the smart contract created on the blockchain on behalf of the end users. And again, the validity of the smart contract must express the access to the possibility of access to data. And again, also any intelligence AI processing of health data is performed when permitted by the smart contract using the proper artificial intelligence workflows or using the federated learning central system. So in summary, the main users here are the end user, of course, a user whose health-related data are collected by the IIH platform, the third-party user, any third-party entity like hospitals, clinics, doctors, research centers, caretakers, and other relevant entities. And we can add external data sources representing either platforms other than the IIH platform, or from which the backend may collect, or even the front end may collect subsidiary data for the integration of relevant information towards health-related intelligence services. Speaking about services, the other main point here are the services. We have already identified the front end, the back end, and blockchain and distributed ledger technology, and of course, the artificial intelligence services selected from the MPI store and displayed as possible by the platform backend. And the other main point to be made is, of course, the Intelligent Computational Service Organization. Basically, we have a centralized federated learning that services the front ends and acquires intelligence towards medical diagnosis or medical alerts. And of course, this includes the federated learning clients, the mobile applications, but we have also multi-sourced AI models that are selected from the MPI store and displayed in the backend to directly treat and process data on the device to extract some specific knowledge sought by the third party with contracted rights. So next, I'd like to talk a little bit about the first, some requirements. The first slides are about the smart contract functional requirements, which are no more at this moment that what should be expected. We must have smart contract to specify exchange of data and processing of data acquired by the end, from the end user to the backend, which should at least list the following records. Then we have the interaction between the backend and any third-party entity that is registered. And this will mostly identify and validate the third-party entity to the backend. And finally, seen from the point of view of the third-party entity to the backend, also some requirements towards what should be expressed in the smart contract. In terms of what are looking for are proposals that can represent at least the following data types and also the possible associated metadata. I'll go rapidly through which one of these, but I leave time series for last. So beginning with historical user health data, of course, it might possibly be represented using a markup language or JSON. But it should feature end users' medical history, lab or exam results, and other important health-related information that can be used to predict or to inform treatment, to predict the disease or inform treatment decisions. In terms of sensing data, this includes data from sensors in wearable devices by the end user, smartwatches, fitness trackers, etc., which can be used for monitoring vital signs, tracking activity levels, detecting falls, and so forth and so on. This information is basically used or should be basically used to monitor physical activity and promote healthy behavior. The data format should include the data types and their units of measurement. In terms of geolocation data, of course, at least the geographic location of end users, it serves to be used in conjunction with other types of data. Social media data, again, this could include chats, posts, comments, and so forth, but it's basically used to understand, for instance, the public perception of health-related topics. So a third party could be a government, or identify trends in health related or behavioral related, something like that. Monitor spread of disease, monitor misinformation. Again, this could be all that is related to unstructured data. When we talk about unstructured data, we talk about, of course, textual health data, which also includes clinical notes and medical literature. Health-related video data, for example, self-taken videos that can be used for remote demonstration of a particular physical health situation. The same for health-related image data that could include self-taken images or could include medical imaging. Audio data, for instance, can be used for anomaly prediction or medical information when the user speaks or cough. There are some at least pneumonia signs that can be easily caught. Genomic data, well, this includes DNA data and other types of genetic information that, for instance, can be used to predict the risk of a certain disease or inform personalized, customized medicine. And finally, what I left before, time series data, which are vital measurements such as heart rate, blood glucose, blood pressure, and so forth and so on. They are taken throughout the time, and again, may be used for predicting disease or informing personalized treatments. All of these, of course, to be secure and to be sure of exchange, it should not be exchanged without using an aggregate health data format. Which only means that we use a container to carry all the data from a front end to a back end, or eventually from a back end to a third party if authorized. This could be possibly used. This could be possibly achieved using an health electronic record. Since these improve the efficiency and security and quality of healthcare, by providing the medical team with a comprehensive, up-to-date and accurate information about all of the patient's health history and living context. An example that we find interesting for a standard is the HL7 FIR. That allows healthcare information to be available, security to third parties, as long, of course, there's a permission to disclose this health data. So in terms of API, we have an API between the backend and the front end of the AIH platform to provide, of course, the interface between both ends. And we could we envision the use of a REST API interface, providing the access between the components of the platform. And of course, the main requirements here for the API are authentication requirements, namely registration and signing in, storage requirements, which we mean by store, retrieve, and delete. In case of deleting, the user that owns the data can delete it or allow the backend to delete it on whatever conditions. Data stored can also be updated if needed. Auditing requirements also must exist, such as the creation of smart contract, the record of a new permission in the smart contract, or the validation of some permission granted for a third party. In terms of federated learning within the system, this is basically backend to backend, but backend to front end. So of front end to back end. So the model parameters may be retrieved from the central system node to initialize the federated learning local process, and vice versa, the federated local client can send local trained parameters into the federated learning system for possible aggregation and improvement of the federated model. In terms of backend towards third-party users, again, we need to register, authenticate, and control access of third-party users, and we need, in terms of retraining of any health-related data from the front end requested by the third party that is not available of the backend, we need requirements for all these actions and services. And finally, between the backend and the blockchain, of course, we need to be able to create smart contracts and eventually add a specific permission on existence smart forms or validate smart contracts. So we've arrived to a more legal description of what is involved in this call for technologies. I hope I've been able to highlight the main components, actors, and services on this call for technologies. And now I leave the floor to Leonardo to carry on. Leonardo, do you want to keep on passing the slides, or do you want to take control of the slides?
No, I'm fine using your slides. Thank you,
Okay.
Thank you, Anna. Of course, the main component of the call for us technical people is the content of the system that we wanted to build, the interfaces that we want to standardize, the data format that we want to define. But very often, in order to build such advanced system, you need new ideas that correspond to maybe to new intellectual property, patents, and so on. We try with the framework license to lay down some general guidelines that should be accepted by people submitting technologies, and they will be eventually translated into a final license. But MPAI has no say in the final license. MPAI is conveying what the principal members have decided should be the framework license of this of the technologies that underpin this system. So this framework license applies to this eventual standard, would probably be called artificial intelligence for health data or something similar. All contributors to the standard shall accept in writing that they will they have the intention to make available a license for their essential IP based on the condition of use of this license that I'm now going to introduce. Okay. Then we have the first, the standard essential IPR holders committed to issue a license with the following conditions. The license will be in compliance with the general accepted principle competition laws and the MPI statutes. The license should cover all claims, so you cannot say that, okay, I give you a license for this, but not for the rest. No, it should be all claims, and it should be both the development right and the implementation rights. The license will grant access to essential IPR or the standard, and this should happen in a non-discriminatory fashion. The scope of the license, because we are dealing with the technologies that very often are artificial intelligence enabled, may be subject to legal, bias, ethical, and moral limitations. Next slide. Then there will be royalties. and the royalties will apply to a baseline profile of the standard, but if there are other profiles, that it will also apply there. It will apply to any implementation that is based on the standard, but there are exclusions that I will talk about in a minute, and it should be worldwide, should not be for a group of countries only. An implementation of the standard may use other IP to extend the implementation standard or to provide additional functionalities. What are the exemptions? Well, if you wanted to make an evaluation or redeem a solution or technical trial, then that would be free of charge. And a license may also be granted for particular uses if the licensor so decide, and a free of charge license, but that should be for a limited time and for a limited amount of forfeited royalties, will be granted on request. So these are the exemptions. Then, very important, point 8, this is already explicitly foreseen in the MPI statutes. The holder of essential patents will express their preference on the entity that should administer a patent pool. So I want to promote the creation of a patent pool, and we have already done so for other standards that we have approved. The license will be issued before commercial implementation are available on the market. So what we want to provide here is that the answer to the question is say, okay, good, the standard, when will there be a license? Well, before you see commercial implementation, you should be able to get a license. Then the total cost of the licenses issued by IPR holders will be in line with the total cost of the licenses for similar technologies, standardized in the standardization environment. So this is another answer to a very important question, that is, okay, how much will it cost to me? We cannot say it will cost 1 million or it will cost 1 cent. That we cannot say, but we say that the cost should be aligned to what is already to the cost of what is already on the market. And the total cost of the licenses will take into account the value of the market of the standard essential IPR. So this is very important, maybe not for us technical people, but for people who fund your research or have their own plans, it is important to know which will be the condition under which a license will be issued. And as you can see, the conditions are very general, and they are also very reasonable. So anybody is entitled to respond to this call. So there is no limit. But the responses should reach the Secretariat by the 19th of October. There are 4 documents that you are more than encouraged to read, because if you don't comply with what is written there, then we'll be sorry, but your submission will be rejected. Next slide, please. Because of that, and I'm very happy to say that we look forward to working with you on this exciting MPAI project. And there's an easy way to do that. You join MPAI and you will share the fun with us, and you will build the future. Thank you.